right, so we're going to be doing central angle and some arcs. Now first write some definitions down. A central angle is an angle where the vertex is in the center of the circle. And the sides of the angle are the two radiuses. All right, a couple of different types of arcs. We have some classification of arcs. An arc is a portion of a circle. Okay, it's the part of the curve. So a minor arc is going to be less than half the circle. So how many degrees does it have to be less than? 180. So less than half of a circle, or less than 180 degrees. A major arc is going to be more than half the circle, or more than 180 degrees. On your guided notes, guys, you don't have to stay in the little box. Some of you are trying to squeeze it in because there's a line on the paper. You can keep writing. It's okay. No, I'm just not late.
No, I
so
know.
yeah.
I'm
Earlier.
very OCD about lines.
Oh, I'm sorry. Earlier today, they were like, I can't fit it all in, and they were stopping right here. I'm like, well, you have all this space. Okay, and so if this is less than 180, this is more than a semicircle is exactly 180 degrees. So exactly half of the circle. Okay, and we're going to label these on the diagram that you have below on your sheet, okay? I'm going to give everybody just a moment to write down 3 letters. And they do go in order, okay? So if you see an arc that says AFC, you're going to start at A. Then you got to go to F next. So you're going to go through F and stop at C. So you want to trace these as you read them, okay? Major arcs use 3 letters, minor arcs use 2. The other important thing to note is that an arc's measure is the same as the central angle that it is cut off by. Okay? So you might want to write that over in the left-hand column as a little tidbit of information. The arc measure is equal to its central angle. And we're going to use that next in a couple of examples. Oh, I'll raise it up. We're going to find the measure of each of the following arcs here, okay? This is an 80 degree. I don't know if it copied very well on your sheet, so you may need to annotate on your diagram. Okay? This is 80 degrees. Find the measure of the following. So letter A, we want to find the measure of arc MN. Is arc MN going to be a major or a minor arc?
Minor.
How do we know?
2 letters.
There we go. Excellent job. 2 letters. So MN. So we're talking about this arc here. Its measure is the same as the central angle that it cuts it off. So we're looking at 80 degrees. MPN. So we start at M, P. Let's see, this. Go through P and stop at N. Major or minor? Major. It's definitely more than half the circle. 3 letters. All right. Now this one, well, first of all, how many degrees is in a circle? 360. So if this was a pumpkin pie and we cut this little slice out, how many degrees would be left? How did you get it?
80 minus 60.
Okay. 360 minus, but I knew what you meant. Oh, 80. 280 degrees. 360 minus 80. All right. You and your partner, could you please figure out letter C? Talk to one another. 80 degrees. Anytime the endpoints are the diameter, you know you've got a semicircle. So 180. Okay. We got a few postulates and theorems that are on your diagram or on your notes. Congruent circles. 2 circles are congruent if they have the same radius, so same size, same shape. This is already on your page. Congruent arcs. 2 arcs are going to be congruent if they have the same measure, and either they meet the condition that it's the same circle or it's from 2 congruent circles. And then we have arc addition postulate. The measure of an arc formed by 2 arcs, adjacent arcs, is the sum of those measures of the 2 arcs. Okay. So, if you'll look at the examples on your paper, they may not have copied very well, so you may need to annotate or look up here on the screen. The bolded items are kind of in blue up here. And we're going to determine whether or not the arcs are congruent to each other. So letter A. Are they of the same circle or congruent circles? Yes or no? Yeah. We only have 1 circle here. And are the central angles the same?
Yes.
So these arcs are, in fact, congruent. Okay? All right, look at B. Are they of the same circle or congruent circles? Different circles, yeah. They're not congruent circles because they have different radiuses. So this is a no. Even though the central angle is the same, they won't be considered congruent arcs. And then letter C. I don't know if you could tell, but there's a little congruent mark here and here. So that means that the radius is the same. So are they congruent circles?
Yes.
Yes, they're the same size, same shape. And are the central angles the same?
Yes.
So this one is a yes. Okay. All right, moving on. Questions that I can answer for you. Please stop me at any point. Okay. I don't know if I can get it all in there or not. Okay, so we're going to find the measure of each arc in circle B. GJ. Oh. H to I?
29.
How'd you get that?
151 minus 186 cut in half.
Good. Oh, from 180, right? Everybody see that? Mm-hmm. Oh, I can move it over. There we go. So 180. This diagram here. This is a diameter. Ladies and gentlemen, we're almost done. I promise. So 180. That's the semicircle minus 151 gives us the 29. And then how about HIJ? 180, because it's a nice semicircle. Okay. We're going to save the arc length for tomorrow. Okay, so that last example, we'll come back to that particular concept tomorrow, okay? On your homework sheet, you're only going to be doing one side because, again, we're not doing arc length today. So a homework on 10-2, you're just going to do 547. Okay, on the bottom. So please make note of that.